For this lesson, I'd like to solve a system of equations, but now with three variables in it. I'm given three equations, and they each have an x, a y, and a z. This strategy is going to be to reduce it down to two equations with two variables. So I'm going to label my equations. Let's call this the first, second, and third equations. And if I'd like to eliminate either x, y, or z, I'm going to examine the first two. And I'm noticing that there's a negative y and a positive y. So if I add these two equations together, I'll be left with the x's, the z's, and the y's will be gone. So let's try that. I want to add the first and second equations. When I do this, that's 2x minus y plus z is equal to 2, added to negative x plus y minus 2z is equal to 1. When I add these together, I'm left with x. The y's cancel. I have minus z, and that's equal to 3. So here I have, well, it's just one equation, but at least one of the variables is gone. So I'd like to somehow I haven't used the third equation yet, but I'd like to somehow use this equation with one of the others to eliminate the y in it. And I'm seeing that, well, just like with the first and second equations, if I had the second and third, I have a positive y, a negative y, so those will cancel, leaving me with just an x and a z. So that's going to be step 2, to add equations 2 and 3. So that is, we have negative x plus y minus 2z is equal to 1. I'm going to add that to 4x minus y plus z is equal to 6. So when I add these together, okay, now I have 3x, the y's cancel. I have a negative z, and that's equal to 7. So at this point, I've used all three equations, but now I've reduced it down to two equations with just an x and a z. So that's the goal now. Take these two new equations and solve for either x or z. So let's see how that goes. So I'm going to copy those down again. I have x minus z is equal to 3, and then 3x minus z is equal to 7. I'm going to try to cancel the z's. I'm going to do that by taking the first equation, and I'm going to multiply it by negative 1. That way I'll have a positive z in the first and a negative z in the second. So let's write that out. That's negative x plus z is equal to negative 3. Now, the second equation I'm just going to leave alone. So that's just 3x minus z is equal to 7. If I now add these equations together, I get 2x is equal to 4. That's just one equation with one unknown. It's very easy to solve for x. I can just divide both sides by 2. And I have x is equal to 2. So that's great. That's part of the answer to this problem. It's just that, x is 2, but I still need to know y, and I still need to know z. And I can use any equation that I currently have to figure those things out. So let's see. If I know x, and let's say I want to figure out z, I'm going to look up to this equation. Because I have an x and a z in it, I'll put 2 in place of x and solve for z. So let's write that out. So using this, I have x minus z is equal to 3. I'll put 2 in place of x. I'll subtract 2 from both sides. Divide both sides by negative 1. And now I have a value for z. Z is equal to 1. Put that over here. So I have x, I have z, I just don't have y. And like I said before, you can use any equation that has all three variables in it to figure out the y. So let's see. In equation 2, I know x, I know z, I just don't know y. I'm going to use this one here. I'm going to put 2 in place of x and 1 in place of z. So that is my equation, negative x plus y minus 2z is 1. I'm putting 2 in place of x. I'm putting 1 in place of z. This simplifies to y minus 4 is equal to 1, and therefore y is equal to 5. So now we're done. I mean, these three numbers should make all three equations true at the same time. So we don't have to really plug that into check, but you could if you'd like to verify your answer. And this is the final solution. X equals 2, y equals 5, and z is equal to 1.